Alrighty, y'all, so on the study guide, number 1 wants to know what it's symmetric to. Now, I picked origin on this one because if you look at the graph and you turn this graph upside down 180 degrees so that this is the bottom and the bottom is the top, you will have the same exact picture, which means it's symmetric to the origin. So I chose origin. Number 2, same question. I chose the x-axis because if I take this graph and fold it across the x-axis here, this top part lands on the bottom part, which means it's symmetric to the x-axis. Number 3 was even or odd. I chose even because if it's even, it's symmetric to the y-axis. If it's odd, it's symmetric to the origin. Well, if you look at this graph, if I fold this graph across itself on the y-axis, this side will land on that side, which means it is symmetric to the y-axis, which means it is even. Alright, then number 4. I wanted to know how I could obtain the graph of x minus 5 squared minus 9 from the graph of y equals x squared. So on this, you got 2 moves. You got that negative 5 inside the parentheses, and then that negative 9 on the outside. So the negative 5 on the inside of the parentheses goes left to right. Since that's negative 5, this actually moves right. So it moves 5 to the right. Then this minus 9, remember at the end, if it's positive, it goes up. Negative goes down, so this one goes down 9. Okay? So I think on y'all's answer sheet that would have been D. Alright, number 5 is the same type of question. They gave me the negative square root of x plus 4 from the graph of y equals square root of x. Alright, so that negative on the outside is going to reflect me across the x. And y'all haven't even learned how to reflect across the y, so you cannot pick anything that says the y-axis on that. And now the radical, we treat it like parentheses, so you're actually attacking the x inside the parentheses, so it's going to go left or right. Since that's a positive 4, this one's going to go left 4 units. Now watch out, they try to put one that said left negative 4 units. Well, you can't go negative 4 units in distance. Remember, we're looking at distances on those, okay? Alright, so on that, and I think it was D also. Alright, number 6, they wanted me to solve this. Now, since you already got a 0 over here, they've already factored this side, so what we come in and do is set each of these factors equal to 0. So we're invoking what we call the zero product rule. Alright, so let's solve both of these. Here you add 11. 4x equals 11. Then you divide both sides by 4 so that you get x equals 11 over 4. So that's one of your answers. The second one, solve that by subtracting 1 first. So 4x equals negative 1. And then dividing both them by 4 so that you get x equals a negative 1/4. Now neither one of these fractions reduce, so there's my 2 answers. So since you had 2 x's up here, you got 2 answers. Hey, same thing on this, and you got a 2 for your exponent, so you got to get 2 answers out of this problem. Now, they got a trinomial here, so what we want to do is try to factor this, because we already got a 0 on that side. So we'll factor it and have everything equal to 0 so that it looks like the problem we just did. Alright, so you got an x squared, that's going to be an x and an x. The last sign's positive, so both of the signs on our factors will be positive like that middle number was. So that takes care of all that. Now all we got to do is find factors of 3 that add to get that 4. Well, 3's only got one set of factors, and that's a 3 and a 1. And 3 and 1 do add to get 4. Alright, now it looks like this problem, we set both of these factors equal to 0. And y'all, that's why it's so important that you get a 0 on one side of these equations when you got exponents higher than a 1. Because the only way to solve them is by some factoring or using the quad later. Alright, so solve this first one by subtracting 3. X equals negative 3. Solve the second one by subtracting a 1. So x equals negative 1. So my 2 answers, negative 3 negative 1. Alright, now number 8 wants me to use the quadratic formula. So the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2 times a. Now remember, on my test, you've got to show me work on at least one of these two quadratic formula problems. So you're either going to do 8 or number 9, okay? Alright, so for my problem, A is 1, B is, oh look, we got to do one thing to this first. We need that 0 to be where that negative 16 is, so we're going to have to take this thing real quick and get a 16 added to both sides so that we can get our 0 over there. So you get an x squared plus 10x plus 16 equals 0. Almost messed up writing my formula too close to my problem here. But now, everything's got to be on one side equal to 0 before we find our A, B, and C. If you don't get a 0 over there, this will not work for you. Alright, A is the 1, because there's no number there. B is 10. C is 16. So now we're going to plug them numbers in. X equals, always write that negative before you even start putting in your numbers, because that negative is always in the formula. Alright, then you put in your 10 for your B, plus or minus square root 10 squared minus 4. A was 1 and C was 16. All of that is over 2 times A, which is 1. So, bring down that negative 10, plus or minus square root. 10 times 10 is 100. There's only one negative over here, so that end is going to stay negative. 4 times 1 is 4. 4 times 16 is 64. All of that's over. 2 times 1 is 2. Alright, now we're just going to keep simplifying that radical. So keep bringing these outside numbers down. 100 minus 64 is 36. All that's over 2. Alright, so what we got to do now is simplify that radical before we can add or divide, okay? So bring down a negative 10. Let me bring that up just a little bit. Plus or minus, square root of 36 is 6 all over 2. Alright, so now what I'm going to do is bring that up here and start simplifying it. So I got negative 10 plus or minus 6 over 2. All three of these outside numbers will now divide by the 2, so I get negative 5 plus or minus 3. The 2 on the bottom turns into a 1. Alright, so since this does not simplify further, we're going to get our two answers. First answer, you go negative 5 plus 3. Negative 5 plus 3 is negative 2. Second answer, you do negative 5 minus 3. Negative 5 minus 3 is a negative 8. Alright, so I got my two answers, which is what I needed since I had that x squared. Main thing is do not forget to get all three of these on one side equal to 0. Alright, I got 9 wrote on here too, y'all. Alright, quadratic formula. This time everything's on one side equal to 0, so I'm going to find A, which is 1, B, which is negative 8, C, which is 65. I'm going to plug them into my formula. X equals negative. Now this B is negative, so I'm going to put it in parentheses so I can keep up with there's two negatives now. Alright, plus or minus square root negative 8 squared. Whenever you square a negative number, put that negative number in parentheses. Minus 4 times A, which is 1, C, which is 65. All that'll be over 2 times our A, which is 1. Alright, so now the double negative makes that a positive 8, plus or minus. So always at this step, that 8 should always be opposite whatever that B was there. Alright, negative 8 times negative 8 is 64, minus, because there's only one negative at this end. 4 times 1 is 4, and 4 times 65 is 260, so I got 260. And all this is over 2 times 1, which is 2. Alright, so let's see. I can keep going. Bring down that 8. Plus or minus. Square root 64 minus 260, so 64 minus 260, that's going to give me a negative 196, all that, over 2. Alright, so let's bring that up. That's going to equal 8 plus or minus. Now, since this negative is under that radical, it's going to come out as an imaginary I, because we cannot take the square roots of negative numbers. So then we could find out what's the square root of 196. So second x squared to get the radical, 196. Hit enter, and you get 14, which means that's going to be 14i. Okay, because remember, that square root of negative 196 is like the square root of negative 1 times the square root of 196. Can't take the square root of negative 1, so we replace that with an I. But the square root of 196 was 14, and all we did was write that as what? 14, then the I. Alright, on the bottom is still a 2. So the only thing I can do to this is divide all three of these numbers by 2 again, so that I get 4 plus or minus 7i. Now, since we got one real number part and an imaginary part, we don't have to do this one as two answers, because I can use the plus or minus on this one, because you cannot add i's to real numbers anyway. Okay? Alright, so let's see number 10. Alright, number 10 just wants me to find the x-intercepts and then the solutions. So the x-intercepts is where this is going right across that graph at. So the x-intercepts, remember, x-intercepts have to be the number, and then a 0 for the y, the number, and then a 0 for the y. So that first one looks like it's going across at the 5, so that's going to give me 5, 0. Second one's going to cross at the 6, so that's going to give me 6, 0. Now, they wanted you to solve that, x squared minus 11x plus 30. So to solve it, you set it equal to 0. And we're just going to factor that real quick. X and an x. That's positive, so both sides will be negative like the middle. Factors of 30 that add to 11 are 6 and 5. And remember, now what do? We set both of them equal to 0 like we did a while ago. Add 6 to this one. I get x equals 6. Add 5 to this one. I get x equals 5. So notice the answers are the same as your x-intercepts up here. So we want 5, 0, 6, 0, and then 5 and 6 for our answers, which would be B. Notice they got the wrong signs here and the wrong order on these ones. The 0 don't go first. The 0's got to be second on the x-intercept. Alright, y'all, number 11, a ladder is resting against a wall. The top of the ladder reaches the wall at a height of 9 feet. Find the length of the ladder if the length is 3 more than the distance from the wall. Alright, so I wrote that right here. Here's the 9 feet that the ladder touches up on the wall. I don't know this distance from the wall to the ladder, so that's x. And then it told me that the ladder was 3 feet more than that distance, so that's x plus 3. So I'm going to use a Pythagorean theorem. This side has to be C, this can be A, and this can be B. So if we set that up, C squared, A squared plus B squared equals C squared. A is x, so I'm going to square my x, plus my b, which is 9, I'm going to square that. That's going to equal x plus 3 squared. So here, bring down the x squared. 9 times 9 is 81. Alright, so we got to do x plus 3 times x plus 3 to get that part FOILed. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. Add like terms, you get x squared plus 6x plus 9. So that replaces that side. Now, y'all, if y'all ever take this x plus 3 squared and write x squared plus 9, I'm going to have to get on to you, because that ain't foiling it. That's just trying to distribute that exponent, which is not what you do when you got adding and subtracting. Alright, so let's solve this. To solve this, I need everything on one side equal to 0, because I got these x squared terms. So I would start off by trying to move these to one side or the other. But y'all, when you move the x squareds, they cancel on both sides. So all that's left over here is an 81. All that's left over here is 6x plus 9. Alright, this is not quadratic no more, so all we got to do is solve for the x, subtract 9. 81 minus 9, what's that? 72 equal to 6x. divide both sides by 6, and looks like 12 is equal to my x. So on this, they wanted to know, find the length of the ladder. Well, x is 12, but my ladder is 12 plus 3, which is 15. So my ladder equals 15. Alright, so on number 12, find the vertex. I'm going to use the formula negative b over 2a, f of negative b over 2a. Alright, so a is 3, b is negative 24, and c is 4. So negative 24 over 2 times 3 will give me a positive 24 over 6, which equals 4. So the x value will be 4. Now plug that back into here so that you got 3 times 4 squared minus 24 times 4 plus 4. Alright, so do the exponent first, so that bring down that 3. 4 times 4 is 16. I'm just bringing everything else down at the moment. 3 times 16 is 48. 24 times 4, that's 96, and then plus 4. So 48 minus 96 is a negative 48. Negative 48 plus 4 is a negative 44. So my vertex was 4 for the x, negative 44 for the y. Alright, find the axis of symmetry. So the axis of symmetry is equal to the x-coordinate, which is negative b over 2a. A is 1, b is negative 20, c is 107. So negative 20 over 2 times 1 equals 20 over 2 equals 10. So my line of symmetry is x equals 10. You have to have that in equation form. Alright, so number 14 here wants me to find a min or max. So since that's a positive x squared, it's going to look like a u and be a minimum. So I got to find negative b over 2a first, which is negative 8 over 2 times 1, which gives me negative 8 over 2, which gives me negative 4. Alright, but I don't need that. I need to find that value for the min or max. So I got to put that negative 4 back into this equation. So I got negative 4 squared plus 8 times negative 4 plus 8. So that's going to give me 16. 4 times negative 4 times 8 is negative 32 plus 8. 16 minus 32 is negative 16. Negative 16 plus 8 is a negative 8. So the min or max value is a minimum of negative 8. Okay, so it's exactly what we got there. Alright, so let me do one more on this, and then we'll have to do another type. So to find a domain, I take that bottom, x minus 12, and set it greater than or equal to 0. So I'm going to solve that by adding 12 to both sides. So x has to be greater than or equal to 12. So to write that as an interval notation, 12 is the smallest number, but it can equal 12, so I'm using a bracket, and then it's pointing off towards infinity. So any number 12 or bigger works for my domain. Anything smaller would make it imaginary. Alright, y'all, I'm going to have to stop this video and then make a part 2. Good luck.